Now, if you recall, we said that the graph y equals x squared is a parabola that opens in the upward direction. That looks like this. So now, what if we have a different graph that is associated with that parent function? Let's say x squared minus 3. How can we graph this function? This minus 3 is a vertical shift. It's going to bring the function down 3 units. But the graph is still going to open in the upward direction. So it's going to look like this. So for this particular function, what is the domain and the range? We can see that the lowest x value is negative infinity, and the highest is positive infinity. For any type of quadratic function or parabolic function that looks like this, y equals x squared, the domain will always be all our numbers. Now, what about the range? What is the lowest y value that you see? The lowest is negative 3, and the highest is infinity. So therefore, the range is from negative 3 to infinity. Let's try another example. Try this one, negative x squared plus 2. So go ahead and draw a rough sketch of the graph, and also determine the domain and range of the function. So this graph is going to shift up 2 units, and it's not going to open upward because there's a negative in front of the x squared. So it's going to be flexed over the x-axis, meaning that it's going to open in a downward direction. The domain of this function is going to be the same, all our numbers. There's no restrictions on the value that you can plug in for x. So what is the range for this function? What is the lowest y value, and what is the highest y value? The lowest is negative infinity. The highest is 2. So the range is from negative infinity to positive 2. Let's try this one. Y is equal to x minus 2 raised to the third power. The parent function is x cubed. And we know the general shape for this function looks something like this. So therefore, how can we graph this function? What type of transformation do we have? As you recall from the rules that we just went over, this means that the function is going to move 2 years to the right. If you ever forget, set the inside equal to 0 and solve for x. So the new origin is located at positive 2. So this graph is going to look like this. It's simply shifted 2 units to the right. For any cubic function, the domain will remain negative infinity to infinity, and the range is going to stay the same, negative infinity to infinity. X and y can be anything.